equals negative 27. Okay, so a number by itself means like 2 times 2 times 2. That's 3 times.
Yeah.
1, 2, 3. But that's not the answer. That's 8. Okay. To get to 27, it's 3 times 3 times 3. But we want negative 27.
Yeah.
So this is negative 3, negative 3, negative 3. And that gives you negative 27.
Oh, okay.
Now the reason is negative 3 times negative 3 is positive 9.
Yeah.
2 negatives make a positive, but then you're multiplying it by another negative to get the negative 27, right?
Yeah.
So I just think we should do one real quick here together again. So if I asked you for the cube root of negative 8, it's just like the last problem. I'm looking for 3 numbers that when multiplied by itself gets you to negative 8.
Mm-hmm.
Can you tell me what that would be?
Negative 2.
Yes. Negative 2 times negative 2 times negative 2. That gives you the 8 for sure. The first 2 negatives make positive. With the last one, it makes negative. Your answer is negative 2. Good.
All right.
Okay. Got it. Where should we go from here? Actually, number 4 would be good to do.
All right.
It's really similar to number 2.
Yeah.
So again, that 3 up here in the top, that 3 tells you that you need to find 3 numbers that multiply to negative 64.
Right.
Okay, so like we've already covered a few of them. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. What do you think the next grouping gets you to? So if you're not sure, sorry, go ahead. I'm sorry.
64.
Yes. Yes. And if you're allowed to use a calculator in class, or if you like to use one for homework, like I'm not anti-calculator, I want you to use whatever you're going to use in that. But the problem here is we want negative 64. So how does that change this list?
We just make them all negative.
Yeah.
So it would be negative 4.
Yes. So your teacher expects you to know this list and slightly beyond it. Like they probably want you to know 5 times 5 times 5 is 125.
Mm-hmm.
You might ask in class, like, hey, how far up should I know? That would be a good question.
All right.
Can you tell me the answer to number 3, since we just did something really similar to it? I'll snip it in here.
4.
4.
Yeah.
You got it. You got it.
All right.
Okay, where should we go from here?
So I would say just number 5.
Okay, so we're just going to go in order. Is that right?
Yeah.
That's fine. Yeah, that'll be cleared for me. Okay. All right, so number 5, it says to write this equation in standard form. All right, so you have to first even know, like, well, what is standard form? Do you have any idea what that is?
I mean, I know it's like I've done it before, but
so this is standard form. Okay, and it's like what it's got A's, B's, it's got X and Y in it.
Yeah, I remember that equation.
So it has some rules. Like math's got a ton of rules in it. One is that the first thing here is that X and Y are same side. Okay, X and Y are on the same side. The second is that A, B, and C are integers. So no fractions, no decimals. The third is that A is positive. Okay. Mm-hmm. And I'm sorry for all the rules. That's just the way it is here. I mean, I didn't make these up. They're just the rules. Okay.
Yeah.
All right. So when you look at this equation, I'm going to rewrite it here so it's a little cleaner to look at.
Yeah, sorry about the quality.
Oh, it's okay. It just don't want you to, I don't want to make a mistake here because you probably got to turn this in and get a grade on it. So, All right, so first thing I want to do is get rid of the fraction.
Uh-huh.
What do you multiply everything by to get rid of the fraction?
Multiply everything by.
Yes. And I'm just asking to kind of gauge where you're at here, certain things.
Like 2.
So we're gonna multiply by 8 because 8 is the fraction.
Okay.
Okay, and you multiply everything by 8. You multiply the 1 by 8, the 3/8 by 8, and the 7y by 8. Okay, so let me show you this as an intermediate step. 7y times 8, 8 times 3/8 x, 1 times 8. Okay, so you literally multiply everything by the 8. Have you seen that before?
Yeah.
Okay, it's okay if
Like
you haven't.
distributing.
Yeah, and it's okay if you haven't. I'm just, again, just trying to gauge where you're at so I can best help you. All right, so now on the left here, you're going to multiply the 7 and the 8. Okay, so that's 56y. In the middle here, you're going to multiply 8 times 3 and then divide by 8.
So
What is 8 times 3?
I'm sorry.
What is 8 times 3?
Oh, 24
24, and then divided by 8?
through 3.
3. Yes. So notice, see how the 8s actually cancel when you're all done? You're just left with the 3.
Mm-hmm.
And then
Okay.
and then 1 times 8 is 8.
8. So that would be
So that
would,
go ahead. Sorry, go ahead.
is that the standard form?
No, that
No.
satisfies number 2.
Okay.
Okay. So we need to get x and y on the same side. So we're going to subtract 3x from both sides.
Mhm.
Typically you go left. So this becomes minus 3x plus 56y equals minus 8.
Yeah. Okay.
Now we're really close because x and y are on the same side. The numbers minus 3, 56, and minus 8, they're integers. The last one is that a, the number in front of x, has to be positive. Is the number in front of x positive?
No.
No. So to change that, you're going to multiply or divide everything by -1. My preference is to divide. You can multiply, it doesn't matter, but it changes the signs. Changes the signs. 3x minus 56y equals 8. And now we're done. Now we've got a final answer.
Okay. 6. Yeah.
So normally, David, I'd love to we do another problem like this because I could tell while you maybe understood the individual steps, I'm not sure you could do it from start to finish. And the goal is obviously to get you to be able to do something like this on your own. The Saxon really doesn't help because you get one of each type and then you don't see another one until tomorrow.
Yeah.
But that is what we've got here. Okay, so simplify here. Whenever you have a fraction, something on the bottom, you're going to divide both of these by that fraction. It's not a choice. Both have to do it.
Okay.
You have to divide to both. You don't get to say, oh, I like this one on the left. Okay. So that's the first thing that you do. Okay.
Yeah.
Now I'm going to slightly rewrite this so that it's x times x on top. All right. Now we're gonna do some canceling. Okay.
Oh yeah.
Okay. So if the x is in the top and the bottom, it cancels.
Mhm.
So if x is in the top and the bottom, it cancels. Okay.
Mhm.
And it's okay. It's okay to write steps here. It's okay to just be like, all right, I've done some things. I'm now going to do, rewrite it. I'm not gonna, you don't have to do everything in one step. Right. Now, on the right here, you have the same number on the top and the bottom. So they will also cancel. Okay, but there's a one that remains in the top. It's not 0, it ends up being 1 that's left over. Have you seen that before?
Yeah.
Okay. Now on the left here, 12 over 16. Is there a number that goes into both 12 and 16?
4.
4. So you divide 12 by 4 and 16 by 4, and you get 3x over 4y minus 1 over y.
They don't have to have the same variable to divide, or
No, we can leave it like this. This is acceptable.
okay.
Maybe you're referring to like what's coming up here in the next question.
Okay, so yeah, 7.
7, yep. All right, let me just rewrite this bit. So dm minus 2, it's a 2, isn't it? 2 over
Yeah.
3 plus 5d. Is that, what's the letter with the square? Is that an R, an I? What is
An
that?
M. It's an
Oh, it's
M.
M. It's a
to the
full M.
second.
Okay. Okay, got it.
Sorry about that.
Thank you. Sorry, I can't see better. It's it's clear now. I just was seeing something totally different. Okay. Negative exponents. What do you remember about negative exponents?
You gotta move it down so it becomes positive, or
So
switch it.
this one on the left becomes 3m squared, like you just said. Okay, now I know that there's a lot of letters here and not numbers, which is what you see in Saxon all the time.
Yeah.
All of math isn't like that though. It's not like every problem is symbolic. But simple question here for you. Are the bottoms the same? Is 3m squared the same as m squared?
I mean, no.
No, don't overthink it. I mean, I bet. So
Yeah.
I'm not into like trick questions and deceptive, like I'm very direct.
Yeah.
They doesn't have a 3. Okay. So you're going to multiply the top and bottom by 3 on the right because you want the fractions to be the same. So on the right, it's 3m squared on the bottom. What does the top become?
15D.
Good. Now are the bottoms the same?
Yes.
Yeah, that's good. So when the bottoms are the same, you add the tops. What does the top add up to?
Just 16D.
16d over 3m squared.
Okay. Right.
All right. So this one here, let me just make sure. This is a -6.
Yeah.
And this is a -2. Very good. Okay. So just like in the previous problem, you got to move some things around. Okay. It becomes 8 over h to the 6th, the y squared.
Yeah.
Plus, now there's always a 1 in the numerator. It doesn't like, you don't like get to say it goes away. H to the 6th y squared. So
Y squared.
are the bottoms the same?
Yeah.
So you can add the tops. So this becomes
Oh,
7
okay.
over. Yes, if the bottoms are the same, you
We
add the
can
tops.
add the top.
Yeah, because their bottoms are the same. If they're not the same, then you can't. Like that.
And
That was
why?
the
And
issue.
why is it 7?
7. Oh, because I didn't add right.
Okay.
Thank you. Thank you. Yeah, please, especially late, I make mistakes.
Mhm.
And it's more out of just being
You're
tired than
good.
anything. So thank goodness, finally a fast one. All right, let's see if we can what we can do here for number 9.
Oh, number 9, my teacher told me to skip. He said it was
Okay.
just weird, like weirdly.
All right. Well,
So we can
let's
go to
take
10.
10. Okay. Number 10. All right. Are you excited for the Super Bowl?
A little bit. Yeah.
Cool. All right. A football field has a width of, so this formula right here, that's your width. So they
Yeah.
don't say 120 yards, even though we know it's 100 plus both end zones. Person walks the outside boundary line to mark it with chalk. How far does the person walk? Okay. It's a really complicated way of asking for the perimeter. The perimeter is always a walk around.
Yeah.
Okay. So this right here is also on the other end or the other side here. 360 plus 360 at F over F plus 1. Okay. And then same thing with this here. This is also the same. So this problem is a bit deceptive. We're going to look at this top one here. Bottom one doesn't really matter. And just look at the top. Is there anything that's common in the top? Is there a factor, greatest common factor?
360.
360, yeah. So this becomes, and to figure out what goes in parentheses, you just divide each of these by 360. So what comes first?
1.
1 plus, what's 365?
1
F,
or
just
just
F.
F. Yeah.
And then on the bottom is F plus 1, but you can switch the order. Like you can say, oh, I don't like that order. I like 1 plus F. And now do you
So
see, here's a question?
on the outside of the parentheses, it just goes like what you're gonna take out of each one.
Yes, exactly.
Okay.
So the this is now 360 instead of
Yeah.
that instead of that other thing. We're running really out of time. The lessons you are, we'll get that another time, but this ends up being 160. So your perimeter is the walk around on these. You'll have to add these up.
Oh, okay.
Yeah.
That makes sense. I'm sorry we went over.
Oh, that's okay. We'll just figure it out next time, get it together. So real quick here,